And we're live. Hello, everyone. Welcome back to the Architecture Weekly YouTube channel. Today we have another interview, and I'm happy to say that today I'm accompanied by none other than Pasha Finkelshteyn, a developer advocate at JetBrains. Pasha, welcome.
Thank you very much. Hi, everybody. Thank you for having me. Nice to be here. It's a long time since I last have been talking about data engineering in general, and that's a good opportunity to maybe help somebody else to understand what is data engineering. I don't know.
So if you haven't understand yet or missed the title on the YouTube preview, so today we're talking about data engineering, what it is, what it consists of, what are the popular trends, and so on. So Pasha will help us understand the fields, right? So can you please start with just the introduction, like how you ended up in data engineering, like what fascinates you in it?
First of all, it's incorrect to say that I ended up in engineering. Engineering was one of very interesting steps in my life. I actually have a complicated, maybe even overcomplicated way in IT. I started with technical support, then I moved to ops, which was called system administration those days. Then I became programmer, and then engineering team lead, engineering manager. I went through, I don't know, quite a few positions actually. I don't know, 12 positions for last 15 years or something like that, maybe 10 positions. And now I am a developer advocate at JetBrains for data engineering and for Kotlin. So I mean, it's not my final stop. It's not my final destination. Let's see what's next. But you know what I found, that data engineering was extremely exciting engineering field. I've been mostly a backend developer, lead of backend developers, and software architect, and so on. But data engineering gives you a completely different view of what's going on in the organization. You work with more complete data, you work with larger amounts of data, and so on.
When you're talking about a different picture, a more complete picture of an organization, how like this data engineer compared to a regular backend engineer role? What are the differences in the point of view?
Yeah, that's what I call deep backend engineering. I mean, usually when you're backend developer, you work with Java or Python or Ruby or whatever, but you have your customer very close. They probably make some JSON requests to your backend, and actually your work is to, I don't know, handle this data, drive this through the whole business process, and then put it into database, or just get data from the database, drive it through some logics, and return back to customer. That's all. Data engineering is a little bit different. Our customers are probably very far away, and they usually require us to provide an access to data. Sometimes it's raw data, sometimes it's data that is pre-aggregated and cleaned, and so on. And we usually operate on pipelines, and we operate on data architectures. Like we have to build the whole architecture of how our company will handle all our data probably.
When you're seeing customers, who are the customers for data engineers?
Customers of data engineers are very different people. It can be data scientists, managers, top managers, business analysts, whoever need a data. And actually it's a challenge, because in the usual backend development, you have one concrete customer, one customer that handles your data. It might be your mobile application, it may be your, I don't know, web application. You might provide even raw API like RESTful or something like that. But you know for who you work. In data engineering, it's a little bit different, because you work for very many people, for all kinds of people. Everybody who needs data will eventually come to you and will ask for this data. And you need to figure out the best way, the optimal way, the fastest way, the most reliable way. It depends on requirements. or to provide access to this data.
Yeah, can you give an example, like in a
Yeah, of course.
typical?
So, for example, usually top managers want to see some report on sales of our company, but sales is a complex complex entity. We should process lots of data to, I don't know, to segment the sales and so on. Right?
How is that complex? Because like typically an organization has a CRM, and there should be some built-in reports and like monthly sales.
Yeah. If you are talking about e-commerce, then yes. What if we are talking about sales of I don't know, Bolt? How will it work? How many people made the drives today? From which countries? How old were these people? Who are our target audience? Do we meet our goals or not? They're complicated questions, actually. And you have to handle lots of data, because I believe that Bolt has this event stream, like customer order to taxi and so on.
Well, this is not precisely a sales report, right? Sales report is basically like how many rides we had today.
I'm sorry that I didn't explain it clean enough. Yeah, for sure, I'm talking about more complex entities than just how many things did we sell.
Okay.
You usually want some segmentation, because raw information like how many things did we sell is actually only, I don't know, in very small amount of occasions.
Okay, then what is what is a more sophisticated example? I don't know, marketing, for example, or
marketing. Sure, that's actually a very interesting question. How many people do we convert from viewing a story on our page to viewing product information on in our e-commerce shop, and then to buying it? Like, build this funnel. It's a very interesting task. It requires lots of aggregation and I don't know, maybe even complex pipelines, actually, because maybe today you opened your story and tomorrow you will open the product cart.
Okay, so basically what's happening is that some people from marketing come into you and say, hey, we want to launch a new marketing campaign, but we need to understand what you can provide them.
Anything we have, actually, but question is, how did actually the less interesting part of my work is to provide them with this information. What happens if they need this information daily? How do I build the process of supplying them with this information? Because one time I can count it, I don't know, for 24 hours, and that will be fine. Every day for 24 hours, it sounds risky, because tomorrow it will be 25 hours and I won't be able to provide them with this report in time.
Oh, okay. So basically you're saying that instead of giving the data one time to a particular role, your job is to build tools that those people can use on everyday basis.
Actually, it is what we see. It's one of the trends in data engineering these days. It's called data democratization. Like, we want to empower people to access data, different people, and we don't want to think about it. But it's a very complex task, because if you are, I don't know, very good in SQL or very bad in SQL, both are bad, you will come to our database, you will make some sophisticated query, and it will kill our database for 3 hours. And that's not what we want to, not what we want to achieve. We want to achieve democratic access to data, so everybody should be able to access this data. And we want to limit this amount of corner cases when you kill our database. Or probably we should create a separate replica of data specifically for you, if you are so sophisticated, and then you will query it as you wish.
Okay. So instead of an access to raw tools, you need to build robust, scalable tools
Yeah,
that will
yeah,
not
yeah, yeah.
die on the first query.
Yeah. It's all about distributed systems and designing data intensifications by Martin Kleppmann.
Oh, okay. Okay, that's nice. Cool. So I believe that in order to have those tools, you need some kind of a pipeline, right? That will take the data from the consumer data database, right, where backend engineers put the data in.
There is
And
no
that-
silver bullet. It's one of the approaches you can take. Another approach is, for example, you can stream all your events right from front end to Kafka and then ingest data from Kafka. And
Okay.
then there is still a question how you will handle the data in Kafka. You can put it in some permanent store, like, I don't know, Hadoop, S3, whatever, or you can stream it directly to your analytics database. So people will be able to update their queries in real time. It's called CAP architecture, by the way. It's well described in the internet.
I think you're talking about like a Kappa versus Lambda architecture, right?
Yeah, Lambda is when you have some batch jobs and some streaming jobs, and Kappa is when you have only streaming jobs, and that's what people are usually trying to do these days. Folks, I am very sorry for this because it's already overcomplicated. I feel it, but you really need to read about it.
Yeah, that's an interesting confusion because when I stumble upon the Lambda architecture, I'm like, oh, okay, Lambda functions. No, it's not.
Well, I would even say that Lambda functions work better in CAP architectures than in Lambda architectures.
Yeah, that's interesting. Okay, so let's get back to this. So you have some data sources, right? So it's let's say client-facing applications are providing you with raw data. And this is like a left-hand side of the picture. On the right-hand side of the picture, you have your consumers that want this democratized way of accessing the data. What's between them?
The honest answer is we don't know. It strongly depends on your business, but most probably there will be several components. Like you will ingest data from some data source and you will probably put it in this raw way in some storage, for example, again, S3. Then you will probably need to clean this data and put on the second layer of your storage. Then you will probably create some aggregates of your data and put them separately for different consumers to be able to access them. And then these BI tools and Excel and whatever, I mean, Microsoft Excel, people really use it to access data and aggregate data even further. They will probably access your data from this last destination. This last destination can be relational database. It can be some, I don't know, solution like Apache Ignite or Aerospike, whatever. People access all kinds of stuff. On the other hand, usually data scientists don't want to work with aggregated data. They want to work with clean data. So they will access your data on the second layer, which is called silver. So yeah, the usual concept is you have three layers: bronze, silver, and gold to access data. On bronze, you store your raw data. On silver, you have cleaned data. On gold, you have aggregated data.
Okay, that's interesting. Let's start from the beginning. Why do you need to clean data in the first place?
Yeah, because data is unreliable. That's basically the whole answer. People do all kinds of mistakes. People add events we don't know about. People write, I don't know, dates in incorrect format, whatever. I mean, anything can go wrong.
How come? Like I thought that on the front end you're supposed to clean the data, on the back end you're supposed to to validate the data. So how it reaches the data pipeline in a state where it's needs purifying?
Thing is, nobody cares. I mean, for front-end developers, it's easy to just dump their JSON object. If it's slightly changed, they won't even notice because no types will be broken, nothing. Even in TypeScript, it probably won't be broken because
in runtime there are no checks. Yeah.
Yeah, and in runtime there are no checks. On backend, you are interested in two particular fields of the data. You will get it. You will validate them. You will use them. But then you have to pass the whole thing to Kafka, and you really don't want to check it. Of course, there are things like Kafka schema registry that can validate your messages, but usually people just don't use them. I mean, it's one additional point of failure potentially in your application. And benefit is not obvious because these data engineers can clean all the stuff.
And they're happy with it?
I mean, you can force data engineers to clean to validate and clean data instead of technical things like schema registry, and they do in any ways they do it. And why would we pay for schema registry?
Okay, how's this cleaning process look like? Like the data engineers just say, "Hey, this is not valid. We're skipping this entry," or they try to modify it.
It strongly depends on your business, on your domain, on your business, on anything. Can you lose data, or you can't afford to lose data? In which format you have to use data, and so on. There most probably will be some business rules and some validation frameworks to understand if something is wrong. What to do when something is wrong is a completely different question. Probably usually the best thing you can do when something is going wrong is to drop data and then come to, I don't know, your front-end engineers and ask them why the data is wrong, or to your backend engineers, I don't know, whoever is your source of data. You know, I had this case once in a career. One day we discovered that one of Kafka topics is empty for already 2 months, and we basically we basically lack 2 months of data. And well, it was an interesting experience, nothing crucial, but we lost some part of data set. Data scientists could learn their models on. Luckily, we didn't lose anything critical, but then we started in the investigation, and we came to data scientists or to backend engineers and asked them, folks, why this topic is empty? And they said, oh, it looks like we accidentally deleted the reporting to this topic. And then they returned back their topic, and then we took their operational database and tried to recreate some messages that should be in this topic manually. And that's what we do, actually. That's really what we do. Because when data engineers' work is complete, it happens, it really happens that things just work. And then you only react to some emergencies, urgencies, whatever. When something is going wrong, you're trying to fix it, trying hard to fix it.
Okay, I suppose there were no monitoring on a particular Kafka topic. So it was okay.
Nobody cared, because you know there is an issue with monitoring too. When you have too many monitorings, you just start ignoring minor alerts, and you can accidentally miss one important. Okay. And again, it was not something crucial. It was not business critical. It was just It was just something we would like to avoid.
Okay.
We added more monitoring and so on.
Okay. So right. So we got our data cleaned, and it's kind of ready for aggregation. Like
we should probably talk a bit about tools, right?
Yeah.
What do we use? Well, there are several popular tools in the area. We usually use Spark, PySpark and Scala Spark are the two most used APIs for data engineering, I believe.
And Spark is a platform for big data calculations.
I would say even broader. Spark is a platform for building distributed computation systems. Still, it's very convenient to use for data, for handling data. you work with it like, I don't know, like in your Java, you have some streams and you handle the streams. You basically, for you, it looks like you handle events or I don't know, rows of your data one by one. Actually, it can batch things, it can distribute things, and so on.
So you write a function in Java, deploy it to Spark, and Spark
probably
will run it.
Scala or Python. And these days, I would say that 60% chance it's Python, not Scala. Yes, then you deploy it to some special cluster on Kubernetes. We have many languages and many frameworks in data engineering, and it's also a very interesting thing. But you deploy it, but you should also launch it like once in a while, for example, every 4 hours. And we have a class of systems called orchestrators to launch your jobs.
For Spark jobs.
For not only Spark, any jobs actually.
Any jobs,
I don't know. You can launch Bash jobs. You can launch SQL jobs. Actually, there are quite a few companies who do not use Spark, who only use SQL data or SQL-like databases, like Greenplum, for example, or Google BigQuery or Amazon Redshift. They also have orchestrators, but these orchestrators do not launch the Spark jobs. So they launch SQL queries that take data from one place and put it to another place.
But it's a matter of API, right? So SQL is just an API for a job.
It's a matter of many things, actually. It's a matter of cost optimization, actually. What is more optimal for you? How optimizer works on this database and how optimizer works in Java or in Scala. Where you have more expertise, like in SQL or in Scala, and so on. So it's a really complex topic. You cannot just say that we will use this technology. You probably should count your money if you are not infinitely rich, and nobody is infinitely rich.
Yeah, nobody, even Google. Yeah. What amount of data we're talking? Like, is it gigabytes per day?
It strongly depends. I believe it was Google who published a paper that said that most of the companies who use Google BigQuery have less than 1 terabyte of data.
Yeah, that's a very funny thing. Like big data is not that big actually.
Yeah, so, but in big companies it will be easily terabytes, petabytes, and so on of data.
Terabytes per what? Per month? Per year?
Depends. In Lambda, huge Russian e-commerce, it was something like several hundred gigabytes per year, and it was growing. So it was terabytes per, I don't know, 5 years.
5 years, yeah, okay.
It was growing, I believe. These days it can be even petabytes per day.
Yeah, but like a couple of terabytes per 5 years, that's just like 2 disks, right? So that's not huge.
Wait, I say terabytes. I wanted to say petabytes, of course. Sorry.
Oh, petabytes. Okay.
Petabytes. Yeah.
That starts to make sense.
Yeah. Of course, it wasn't something about terabytes. I'm very sorry. The biggest operational database in Lambda was 5 terabytes.
Okay.
And it was Postgres, and it was hard. Of course, data engineers worked with petabytes of data. And in bigger companies, I don't know, in Uber, it can be easily exabytes. Because they have, I don't know, they store everything. They don't even know what to do with it. Still, they store everything. But yeah, data engineering, these days, I tend to say that data engineering is not always about big data. It's about data pipelines and data architecture. Because question of data pipelines is always actual. Even when you have, I don't know, 50 megabytes of data, you need to have some processes to handle it.
Okay. So what I'm hearing is that, like, it sounds to me that the question of parallelization of jobs and processing, like any kind of data you could face, is pretty much a solved problem, and you need to.
Well, it's not what we are usually solving manually. Let's say that this way. Because all these frameworks, including this distributed SQL, solve these parallel things for you.
Okay. That's what I'm saying. So there are tools that will solve this problem for you, and you need to pay attention on what exactly you're doing with data. So it's more business
And which tools do you
focused.
use?
What do you mean?
I mean, they solve, let's imagine that we have some green plum cluster, for example. And green plum is basically distributed Postgres. Okay, so now there is a question. We have 5 terabytes of data, not so many. And we have 1 gigabyte of data on one node and 100 gigabytes of data on another node. And now we need to join this data. How will it work in green plum? Is it important if we write A left join B or B left join A? It's a complicated question. Theoretically, it should not be important. Green plum should be able to think for you. In practice, it's not always the case. Even the major vendors, like again, Amazon Redshift, has suboptimal optimizations sometimes. And you should know about them and you should care about them before selecting the solution. Because when you have selected Amazon Redshift and you already have 5 exabytes of data there, it's too late to migrate to better solution.
I'm not sure, because in both we recently migrated from Redshift to something.
What? Snowflake?
No. It's not AWS based, because
Snowflake is not AWS based per se.
Oh yeah, okay. So it's not cloud provided, something on our own. So
well, it's interesting.
Yeah, I forgot the name, but yeah.
Yeah, that's fine. That's totally fine. I mean, of course it's possible. Of course it's possible. Question is if it's economically efficient, how much time will it take, what risks will you have, what's your migration procedure. Migration procedure is a crazy interesting thing. I mean, you have live stream events going right into your Redshift. How your switch actually works to the other solution, even if it's, I don't know, Snowflake, whatever. How do you make the switch that 1 second you have all your events in Redshift, and in the next second all the events go to Snowflake?
No. You're right.
You don't.
You write both sources at the same time,
yeah.
and then you compare that you have the same thing, and
yeah, and you hope that you will have the same thing eventually. And what happens if, I don't know, write to Redshift failed and write to Snowflake succeeded? Our data is a little bit diverged. How will we work with it? I know we will clean our data. Actually, we'll just delete the whole write altogether. Most probably, or we will try to recreate it somehow. What if our timestamps will conflict in different databases? Is it possible? I don't know. We hit some region in AWS that is located in Europe, in US, and suddenly time is incorrect. How should we handle the situation?
Yeah, across the time change, daylight savings. Hello.
Yeah. Well, we try to always write daytime in UTC, and hope that we know our client's time zone to be able to convert it. It's still a challenging task. Well, okay. I mean, lots of challenges there. It's very interesting. That's why I find actually data engineering exciting, because in backend engineering, you usually don't care. You have your one database, it works. In the worst case scenario, you will hire some consultants who will help you to optimize your queries. In the second worst case scenario, you will have to remove your ORM and use plain, I don't know, database queries. That's all what can happen. No complex pipelines, no these risks about time zones.
Worst case scenario is a DBA coming to you saying, "Hey, this query is too heavy. Just split your data, remove all data to some other partition, and go on."
Yeah, well, it's what actually happens. So yeah, for me, data engineering. But you should know, in data engineering, there is much less code than in usual traditional backend development. Much less business logics and much more thinking about data distribution, all these concurrent algorithms, ways to optimize something and so on. Actually, this data engineering is usually about optimization of very different aspects. I thought that I know SQL before joining data engineering. I knew nothing about SQL. I mean, nothing, because people do extremely complicated things. They can do everything in SQL.
What was the most surprising thing you discovered?
I don't know. I don't think it was like one surprising thing. It was more of this guy just wrote 15 CTEs, one of them recursive inside one query, and some window function inside it, and it somehow works. And actually, it works better than something I would write in Java works, because it works right on the data, next to the data. It's a very cool thing.
Okay, is it a matter of just knowing some cool syntax, or it's a database?
It's a matter of, usually it's a matter of understanding. Well, yes, it's about, as we know, SQL is a declarative language of fifth generation, and probably the only language of fifth generation. So you think that you just describe things, but you actually should know very well how you can describe things, because sometimes you don't even think. You write some joins, I don't know, and that's all. But actually, there are much more depth to it. You can do the same thing in very different ways, and these ways depend not only on your preferences, but also on data, your particular database specifics. Like, will Postgres optimize this? Will MySQL optimize this? Will Redshift optimize this? They all have very different optimization engines, and you should know the specifics when we are talking about big data.
Okay. Let's get back to our pipeline. So we ended up talking about the tools that we're using, and we made the first step about cleaning up the data. So it's still the same Spark jobs or whatever.
Yeah, probably the whole thing can be described with the Spark jobs.
Okay. What happens at the next moment, right? So we
have this clean data. Now we have to create our goal layer. We know all our consumers, all our customers, and we just know their business needs. We implement ways to aggregate data in a way they need. The most challenging thing is here usually is on the silver layer, you have a huge, I don't know, event stream. And event stream is the biggest thing you have in your company. And it's usually insanely huge. I mean, it might be terabytes. Okay, now the question is, how do we aggregate it to multiple small tables or multiple small reports as fast as possible, as parallel as possible, as reliable as possible? Again, depends on our business needs. And usually these aggregations depend one on each other, or one on another. And they all depend on this clean task on the event stream. So here's again where orchestrators come in handy. You take thing and you say that this job depends on this job, the third job depends on second job, fourth on the third, and so on. And you build the whole tree called DAG, directed acyclic graph of these jobs. And leaves of this graph will usually be what your consumers need.
Consumers, okay. So this is what it means by the term pipeline, right? So you start with one cleaning job or set of jobs, and then you have trees of other jobs, maybe multi-layer.
Yeah, right? It might be important that you basically never start with one thing. You also need to create a copy of operational databases, just because folks update data there, and you need some snapshot of the data at this moment. You usually also interact with some APIs. Usually you interact with some models. I mean, I don't know, neural networks or whatever. And they all are parts of this DAG, huge DAG. You have many inputs and you have many outputs.
Okay.
By the way, you of course read from relation. You usually have some temporary relational database tables, which you use to, I don't know, to put some signals in it that you can start your job.
Okay. What is the typical team of data engineering?
No such thing. It strongly depends on your business. I'm very sorry. I will say it many times during our conversation. In smaller companies, you maybe don't even have a distinction between data engineer, data scientist, or any other, I don't know.
What really? What really?
Yes.
I mean, yeah, I have an understanding about the difference between a data scientist and data engineer, but I may be wrong. So can you cover it for me?
Yeah, so we have this boom of, how do you call it, cloud technologies, software as a service, and so on. And usually a person without deep understanding of everything or anything can create quite an interesting solutions pure on this software as a service. Like, I don't know, let's talk about Microsoft, for example. They have all kinds of neural networks as a service. You don't need to understand this data science yourself at all. You just put your data there as an input and get your data there, from there as an output. And then they also have this orchestrator thing, Azure Data Factory, that allows you to build pipelines and orchestrate all the jobs. And they also have the Azure Fabric, which was released like a week ago. That is like data factory, but also includes BI. So you can not only build the whole pipelines, you can also build the final dashboards. Of course, they won't be as sophisticated as professional BI engineer could build, or professional data analysts could build, but it will be enough for a startup. And it's kind of very beneficial for you to have a very low headcount. Like, we have one person responsible for data, for example, and a huge bucket of services. When it won't be enough, then we will hire more people, I don't know, replace those services with our handwritten and so on. But right now, it's just economically more efficient to be all in one. Then
so it's like kind of a frugal approach to data engineering. You just go to the cloud, request a bunch of services, and have one single engineer working with them. But it doesn't answer the question of the distinguish between data engineer and data scientist.
Sorry,
like one moment. My perspective was, like, I may be wrong on that one, is that data scientist is not probably an engineer, but it's a person who is who wants to get the business insight from data, like what marketing campaign we should launch on our young audience, for example, or should we I don't know, should we introduce the discounts or the level of discounts, and so on and so on. And data engineer is a engineer who just, you know, work with those tools, work with data pipelines and so on. So they're kind of engineer and business people. No,
it's hard. Again, even this, I'm not even sure that all the companies have the same vocabulary. My understanding is data engineers are more about production, about creating production-ready solutions, and data scientists are more about research and trying to understand how can we solve some particular problem. This leads to very different this distinguishment leads to very interesting outcomes. Sometimes your data scientists cannot write a sensible code. They write something that just works, and data engineers rewrite the whole thing. But they already know how it should work, and they can rewrite it.
What? So data scientists, they're just like, here how the results look like?
Usually, again, it's not a rule, but it's how it usually happens. Data scientists just experiments in a random Jupyter notebook without data versioning, without version control, without anything. Even you can't even run this Jupyter notebook from top to bottom. You have to know the exact order of cells in which it will work. And then data engineers looks at it and tries to understand how it should be written as an actual code. and then it goes to the version control and so on. And probably in worst case scenarios, again, it will be supported not by data scientists, but by data engineers. All the improvements will be made there by data engineers because they know how to write code. I don't like when it happens this way. I find it, I don't know, offensive actually to data scientists. I believe that everybody can write production ready or almost production ready code, but sometimes it's how your economics work. For you, it just makes sense. You don't have much data engineering work. So you hire lots of data scientists and a couple of data engineers that are trying to improve after data scientists. Because it's very, when you know what you're doing, building on this pipelines takes, I don't know, weeks, months, not so long. Then we don't want to fire you. You're a useful person, but we need to spend your time in some sensible way. It's one of the possible approaches. I was lucky to not work in such teams. In my teams, data scientists were always knew how to write the actual code, production ready or almost production ready code, and data engineers were responsible for democratizing data, monitoring, putting neural networks to the production and so on. So for me, data engineering is more of a work about production, and data science is more about research. But outcomes can be different.
Okay. So now it's more clear, I think. Okay, so do those scientists and engineers, they work together on the, on the pipeline?
On the pipeline, usually no, because, well, let's be honest, pipelines are a domain of data engineers.
Okay.
Usually data scientists know about pipelines, and they probably can look at how pipeline works, but they won't interact with these pipelines. They won't launch anything. They will probably go to data engineers and ask them to improve. But I always stand for the idea that it should be either a single team or two very friendly teams, and they should work together. Again, there are lots of exclusions, and sometimes companies prefer to have engineers and scientists isolated. And in this case, usually it's engineers who solve all the problems.
Okay. Does this pattern of platform engineering apply to data engineering as well? So,
kind of. There is, well, first of all, data engineering by itself is a platform engineering, because you create a platform where different people can do different things that they need: data scientists, marketing specialists, managers, and so on. On the other hand, there is a third role we didn't mention today that is called ML engineer, and these folks are responsible for deploying ML models into production, and it's a separate, huge, and very interesting area. And it's also about platform engineering, because they create a platform to run all the modules smoothly. They know how to scale it and so on.
Okay. Who is designing the whole pipeline? Is there such a term as data architect?
Yes, for sure. And I believe you have this title from AWS. You're a cloud architect.
No. I was a cloud architect for GCP, but it's
basically the same.
No. It has very little with the data itself. So it's about virtual machines like PaaS versus IaaS, picking up the proper storage, configuring the monitoring, picking up the database, but not about the data pipelines.
Well, picking up a database is already a completely data-related decision. It's very important.
Well, yeah, but it's usually not about the data pipelines. It's about storing this consumer data. So it's like,
which is data engineering.
Okay.
Nobody thinks about it, but it's pure data engineering.
Yeah, but we started our conversation from the point that, like, hey, this is where the backend work ends and then data engineering starts.
Yeah. So, yeah, of course. First of all the major cloud companies, cloud providers have their own dedicated cloud data architects who can help you building whatever you want. I don't know how do they work, but they basically know everything about products company has, and they have a direct contact to developers. They can ask for some improvements. They can come back to you with some solution and so on. They're basically solution architects for data. Of course, you can have, and it's what, for example, Klarna does. They have their own data architects, more than one actually, that are responsible for different domains. They make different decisions depending on their domains. And each data architect in Klarna has, I don't know, hundreds of people working alongside with them.
Okay.
So yeah, it's a huge thing. But in smaller teams, you definitely won't have a dedicated person. You will just, that's what we did in Lambda. We did have this, I don't know, casual discussions. How should we solve this problem? We had some minor brainstorms, how it could be solved, and then we documented in our ADR and then implemented it. That's basically all.
Okay. Architecture done by team. Okay.
Yeah. It can work to the, I don't know, until some size of the team.
Okay, cool. What are the common challenges you face working with these big data pipelines, and what are the solutions to overcome them?
Well, all kinds of. You basically should know everything about everything. If you want to be the ultimate 10x data engineer, you should know everything about Python, everything about Java. Just one example, what might be useful when you know Java in data engineering. So we had this huge Spark pipeline that worked for, I don't know, many months. And then one day it started failing with out of memory error, and nobody understood what happens. And monitoring was fine until out of memory. You know, what should you do? I mean, you have, I don't know, 50 nodes that run your query. How do you understand what's going wrong? Well,
logs, traces.
Well,
I don't know.
Logs usually do not give you anything sensible, and Spark works in, I don't know, 90% of time in unsafes. So you won't have anything in your logs. You will
oh my God, really? In unsafe?
Yeah, absolutely, because it's much faster.
Okay.
You do not have to. They do not allow JVM to manage memory, and that's very cool. I mean, that's very sophisticated and very cool.
Why use Java then in the first place? Because of, I don't know, tooling?
Because in Java, it's easier to write and safer to write all other parts of your code. Code generation, for example. Code generation in Spark is very interesting. And I don't know.
Okay, let's back to the example.
Yeah.
Okay, you have Spark jobs
but any person with knowledge of JVM knows that there is something like XX on out of memory error, and where you should put a thread dump. Okay. And then you have the next problem, not thread dump, heap dump.
Okay.
Heap dump on out of memory error, of course.
Yeah.
Then we have the next problem. This node that failed with out of memory error had, I don't know, I don't remember actually, 50 gigabytes of data. How will you process this heap dump? Because you actually probably need a separate Spark server to process this large heap dump. But again, people who know something about JVM they know that there are several tools, and one of them is called Eclipse Memory Analyzer tool that can handle in a very limited resources very big snapshots of data.
Okay.
And then you're starting then you know how analyze this.
So that's starting to become a very hardcore Java engineering instead of that data engineering.
Yeah, totally. So I mean, if you are an ultimate 10x data engineer, you should know everything about everything, because you will hit all kinds of issues, really all kinds of issues.
Okay, so basically it's pushing the technology to the edge, right? So facing every problem out there. And
yeah, especially if you're a big company, or if your resources are very limited. If you're a big company, you will have this extremely huge installations of Redshift and whatever. and you will hit the limitations of Redshift, and you won't be able to fix them because they have a dedicated team of developers who can try to fix them, but they didn't even think that this corner case could occur. And if you're a small company that has very limited resources, you will hit these barriers, and you will need to find these ways to debug things and optimize things.
Okay, I believe those engineers should be super expensive, right? If you're supposed to know everything about everything.
Yeah, but they don't. Thing is, they don't, and that's why you usually the thing is that's why you usually have a team. Pasha knows about JVM, Vasya knows about Python, Igor knows about Spark, Жанна knows about Flink, and they all have different areas of responsibilities. They all have some spare time to research things, because otherwise you won't be able to do anything but mediocre. And yeah, this way they still are expensive. I believe these days data engineers are more expensive than data scientists, for example, for the reason they below or above. They can make things into production, and data scientists usually don't. They know some maths, that's cool, but there are lots of people who know maths and this is the reason why there is no such thing as junior data engineer, basically.
Why though? How do you end up in data engineer? You're like senior engineer with super, and then you decided, well, data is interesting.
You move from one of neighbor areas. It's either data engineering or data science or something like that. Maybe you was database administrator. They all work, and they all have their strong parts, and they migrate to data engineering because, well, it's more multifaceted, I believe.
Okay.
And then when you understand them that you don't have an actual influence on the product, you're trying to migrate from data engineering to developer advocates for data engineering.
Okay.
Yeah, it was just jokes, folks. Sorry.
Yeah, got it. Imagine you have a new project or new system, right? Like the client facing is built, and then this is like a new data science project, I believe, comes in. Like, how do you approach designing like a data model, a schema for this kind of a setup?
As always, I have to know constraints. I have to know wishes of the business. What do we want to implement eventually? And with
business always wants insights, right? So like,
but they have to know which insights some of insights data science team can find, like they really know how to dig the data. For them to be able to dig the data, it's already a customer. I have to provide the access to this data as fast as possible, and so on.
What is the first step? Like you just give them the
my first question is how much money do we have? Because if we have close to unlimited amount of money, then I will just select some very fast database like Snowflake, and I won't care about costs.
But that's not the case usually, right? So typically what typical business wants, like a very common situation is like, I want to increase the average check by 20%. I want to increase the revenue by 30%. I want to, I don't know, expand to new markets. Like what you guys can give.
I definitely cannot help in checks. I am very far away from the actual product, actually.
Okay.
And about new markets, but revenue.
Okay.
I am somehow related to the revenue. So my question is always about budget and about business constraints. We will usually have some personal data related constraints, like we cannot store something somewhere. We usually have some other kinds of constraints, like, I don't know, in companies like JP Morgan, you probably won't be allowed to use cloud services at all, for example. Usually it's the case. And then, and knowing all these constraints and my budget, and I will try to plan my workforce. I mean, at least, how do you say it? Well, in a draft. and then I will try to understand what can I achieve. When we are talking about data modeling, it's a completely different story. It's very interesting, and it's about my assessment of risks and consumers. Like, for example, there is such thing as a sixth normal form of data storage. There are not too many companies who use it because of reasons. It's very, very normalized way to store the data. Basically, every table in your database has only two columns, ID and the value. That's all. And you have, I don't know, hundreds of joins in a complex queries. Sometimes it makes sense, but it should be my assessment if it makes sense in our situation, because it is basically unusable by mere mortals. You should build some layer on top of it, some views or materialized views, something like that, that will pre-aggregate some data for them, join it in some sensible entities that they will be able to work with. And on the other hand, there are highly denormalized systems, like, I don't know, like what you can store in Cassandra. You can have hundreds of columns of data.
Yeah, just columns or documents, right?
In Cassandra, there are no documents.
No, not in Cassandra.
In general, yes. And actually, this thing about documents versus relations versus graphs is very important too, because it again depends on the business and its constraints and its needs, because sometimes we need to join absolutely random things. And
why?
We want to understand something we didn't even think about. Like, for example, let's talk about coffee shop.
Okay.
Coffee shop has hundreds of kinds of coffee.
Okay.
Each kind of coffee has its very different rates. How is it roasted? Which taste does it have to it, and so on. And
like fruitness, sweetness.
Yeah,
right?
fruit. Yeah. Berry, chocolate. I don't know what, many citrus things, and so on. I prefer more acidic coffee, so I know only about berries and citrus actually.
Okay.
So yeah, and you also have customers that also have very different traits to them, and you wanna, I don't know, find weird relations between customers through coffee. Like, I don't know what they buy, why they buy, and deduce something about their taste they don't even know.
For example,
given
teenagers prefer more sweeter.
Teenagers is not very interesting. Like Vova Ivanov, we believe, based on what he buys, prefers to have an acidic coffee.
Okay.
Because we can build a path on the graph that will prove that, I don't know, 90% of coffee he bought is acidic.
Okay.
And we will try to, I don't know, offer him to buy such a coffee.
Yeah. So the value basically is understanding the demands of the customers to suggest them the products they will likely
For example,
buy.
Yeah, I mean, it's first of all, it's very syntactic example. Better example of when you want to have a graph database is when you want to build a social graph, and you need to find a shortest way between two people. You actually usually need to solve this task, and without graph database, it will be really hard, because we all have, I don't know, hundreds, thousands of friends and followers and so on. With graph database, this is just a matter of one simple query.
Okay.
From this to this, find me all intermediate nodes.
Yeah, that's interesting. Okay, let's talk about data governance. So, like, I know the term, but like it's complete darkness for me. Like, what this data governance means.
It's a funny thing, because data governance was coined as a term like when I was already a data engineer. For me, it's just a part of work of data engineers. There is such a thing like called lineage. Do you know what it is?
No.
Our listeners probably don't. So you usually want to know where did this data came from, right? For example, I have this, I don't know, row in my Hadoop. It appeared there 2 years ago. Why? How? Data lineage is something that answers to this question. It says that, look, it came here from this Spark job, and Spark job read this Kafka topic, and in Kafka topic it appeared from this backend service, and in this backend service it appeared from the front-end service.
So it's tracing. Basically.
Yeah, basically yes, tracing. But we should know that traces in backend development are usually a little bit different because you have only one trace, like it's a line. In data engineering, lineage is a duck again, because you join multiple things, then you split multiple things and join and split again, and then they appear in your databases. And you should know the whole process, how did it appear there? Because this particular field can be a result of join of two tables, I don't know, 5 years ago. You have to know about it. It's a part of data governance. And overall, data governance is about having a clean, explainable, and I don't know, having other good traits to it data.
So again, I'm really not getting. So data governance is just knowing where your data came from?
Well, no, it's also about managing your data in a clean state. It's also documenting your data. Usually it's not enough to have only column names in your table. You should know how do you calculate this data.
So it's metadata, data about data.
Yeah, metadata. There are such things called metadata catalog. For example, Apache Iceberg, LinkedIn Data Hub, Apache Amundsen. They all answer the data governance questions. How do we store our data? Where did it come from? And in which state we expect it to be?
So it's kind of a registry, like here we have source data, here the Spark jobs,
registry
here.
And all the connections, and probably explanations about the physical meaning of the data. Oh, it's kind of funny thing about explanation of physical meaning of the data. Let's assume that you have a gender in your database. Does it say anything to you? It's kind of funny because, well, actually it doesn't. Sometimes gender is a physical term, how person identifies themselves. Like I identify as a man.
Well, it depends what meaning we put in it.
Yeah,
and what is the meaning to the user, right? Because there's gender, there's sex. Those are different things.
Even if I'm talking about gender, it's how I identify myself. For example, I identify myself as a man. Okay, that should be fine. But then in the other table, we also have gender, and it's a completely different thing, because in this table, gender is what this person is looking for in our e-commerce shop. And if this person is looking for child clothes, it's not important for us that they identify themselves as man or woman. In this particular situation, the business gender is child, or I don't know, boy, or whatever.
Okay.
So we should explain what we store in our tables, and that's a very important aspect.
Yeah, that's a very interesting example. I didn't think about that.
Yeah, nobody thought, but I had to implement it.
Okay, nice insight. Okay, clear for data governance. Okay. Next question is about the considerations. Like you mentioned different things like Cassandra or I don't know, like key value storages or something like that. What are the considerations in data engineering for selecting a storage system or a database? Like what?
As everywhere, business requirements and your expertise.
What is the most common thing? Like,
I would say
or it depends on the business domain.
Yeah, we still can find the single more about data storage. It will be probably S3 and all other wrappers on top of S3 for, I don't know.
So it's a default choice right now, like Parquet files in S3, and you're good to go.
Yeah, it's a very simple choice. These days, other things like Data Lake and Apache Iceberg come into play. They also built on top of Parquet files. By the way, I believe they are Parquet, not Parquet. Which is
okay.
I was very surprised to find it. So yeah, they are built on top of Apache Parquet, but they store additional data there. For example, like this row is deleted, this row is updated, and so on. And then it gives you kind of create, read, update, delete possibilities on top of your data. They're still on S3. And all other things work on top of S3 too. And I believe if we have to pick the most popular storage solution, it will be S3. And then all ways to access it.
Okay. And then maybe you will have some specializations.
Yeah. Then, of course, you will put something at, I don't know, Google BigQuery, something in Redshift, something in Google Spanner. It's extremely expensive, but very interesting database, very powerful database. Very, I mean, worth reading the documentation.
Spanner is
Google Spanner. Google Spanner. Yeah.
I thought it was a globally distributed relational database, something like that.
Yeah, it's like almost relational, and it's they say that it's very available, and they try hard to make it as consistent as possible, and very, very expensive.
Yeah, I think Spanner is a source of a lot of scientific papers on computer science with this consensus problems, time synchronization problems, and et cetera, et cetera. It's even it was even the source of this Spanner clock, right?
Yeah, no. Google. It's called Google something clock. It's not called Spanner clock. It's Google something
maybe.
Clock. And it's a very interesting algorithm of clock synchronization. And it's also, well, the problem is theoretically unsolvable, we believe, for now at least, that you cannot have perfectly synchronized clocks across the globe, only locally.
Yeah, because network, basically.
Yeah, basically because network. But Spanner is very cool. It says that it doesn't give you the exact time right now. It gives you like a span of data. I don't know. It's something between 3 and 6 milliseconds after 6 p.m. Well, of course, it works on nanosecond level. No 6 p.m. exists, and you don't need it on this level. But it's just an interesting paradigm. And you have this very small span to try to arrange your data by it. That's still very cool. Well, pricing is crazy. Just look into pricing, and also availability. They guarantee, I don't know, 5 nines after point.
Oh my god, what?
And it's basically unachievable. I don't even know how you can guarantee such things.
Well, the interesting question for me is why would you need this thing in the first place?
No, I actually don't know. But something business critical. I don't. If I
something business critical, but at what scale? Like maybe 3 companies in the world need this.
Yeah, but it should be achievable. It should be very accessible. I mean, something business critical, but very accessible. How much data? How much business critical accessible data should we have? Well, basically everything. Well, I mean, does it make sense, for example, to store data? Credit card informations for Visa in the spanner? Probably yes, because it's extremely sensitive thing. And
if you
want to perform atomic operations on it, probably it makes sense to delegate to Google. I think though that Visa doesn't do it, and Visa does.
Yeah, I think they do their own thing. Yeah. But funny that I thought about the payments domain as well, because
I mean it's
something. Yeah, something global, but very sensitive to transactionality.
Yeah, it's the only thing I can think about. The spanner is being used though. I mean, it's not like dying technology. First of all, Google uses for something, and I believe they use spanner for search, for even storing
for
search. I don't remember. I actually don't remember.
Maybe it might make sense, yeah, because you want to have internet globally, right?
Yeah, but it shouldn't be this sensitive to losses, right? Let's say that you are not, I don't know, consistent for 5 minutes. So what?
Yeah, who cares? Yeah. Okay.
So yeah, but if I were Visa, I would think about it. They probably think better than me, and that's why they don't have it in Spanner. I also believe they don't.
Yeah, I think vendor lock is a bigger risk there.
Well, Google is the only provider of such a service.
Exactly.
So, like, otherwise you are vendor locked on your worst solution. Like,
yeah,
Visa has their own stuff.
Yeah, but you have the full control over your solution. Right?
That's true. But if you are such a major vendor as Visa, you probably have some, I don't know, ways to influence what Google does. Maybe. On the other hand, when you will lose your first billion of euros, probably you would prefer to migrate to Google somewhere else. I mean, sometimes one error is enough.
Yeah, exactly. Okay, I think the last question for now, like, how do you stay updated with the latest trends and technologies in data engineering?
Sorry, I mean, it's impossible. There is a picture called State of Data Engineering 2023 by Lambda. They published it like, I don't know, a week ago. There are hundreds of technologies. You cannot possibly be up to date with all the technologies.
Yeah, okay, let's rephrase it like this. So you have a continuum, right? So for the 0, you're not tracking anything at all. For 100, you're tracking everything, which is impossible. Yeah. Where do you think you are? Like 50%, 70%, 20%?
Maybe 20. Maybe 20. It means that
but it's still challenging.
Yeah, it's challenging. I mean, I'm trying to follow the major trends in data engineering, and we have new major trends basically every half of year, and maybe more often. And
what is the latest?
After the data democratization, yeah, it's data versioning. It's actually a very interesting topic. Like, it's what LakeFS does, and it's very important. Let's say that you have a snapshot of your data from today, and you run your data science experiment and all your data pipelines on top of this data. Mm-hmm. Is it possible somehow to, when tomorrow something will be broken, to roll back to the today's snapshot of the data? Mm-hmm. It's very interesting.
Okay. There's no such capability yet?
There are 2 projects who provide this capability. They're called LakeFS and Apache Nessie. Mm-hmm. And yeah, they're important. Also, security is a never dying topic. How do you do GDPR on top of immutable data? That's very interesting question.
Yeah, good luck with that.
Well, you do. Well, now you do when you have this Apache Iceberg and Databricks Delta.
How it happens? Like, for me, the solution was like, you're not storing any personal data in the data pipeline, only IDs, and then you store the actual entities somewhere where you can delete it.
Yeah, it might be possible, but now it's possible to solve it another way too. Let's put it this way. Now it's possible because we have this quasi-mutable formats of data like Data Lake. We can say that we delete this thing, and well, tomorrow it will probably be deleted, or Iceberg, should I say, maybe. Tomorrow it will probably be deleted, and you won't be able to obtain it from now. Like, I marked it as deleted. It's not physically deleted yet, but it will be deleted tomorrow. But when we are talking about data versioning, it becomes completely different topic because I will be able probably to roll back to my previous snapshot of data with all the data there. It's very interesting.
Yeah, with the deleted marks. Yeah.
Yeah. And actually, you can, well, if you are good enough, you can steal all the data right in the moment. So it's also about security. And 3 years ago, they basically didn't have, well, only the biggest companies had real data access control, because everything else was basically unsecured. If you're a database administrator, you can access everything, and
Okay.
it will be very hard to track.
So no RBC models, nothing.
They tried, but it's a cumbersome topic. And well, at JetBrains we solved it like completely, I believe, 2 years ago with RBAC. That not just RBAC, it gives you all the data, but the data is magically anonymized. So we have basically our own proxy on top of our own data, who knows from RBAC if you can access some data or you can't. And if you can't access this data, but you still need it, we will give it to you in an anonymized way. It's very important, because if you want some, I don't know, conclusions, sometimes you need to track separate people, but you don't have a right to know anything about these people. Like, it's just customer number 2.
Okay, yeah, customer number 559.
Yeah, it will probably be like 7 numbers.
Okay. Still, what do you do to catch up in the fields? Like any newsletters?
Chats toward data science sometimes. Yeah, but casual talking to people is better than anything else.
This is what I'm doing right now.
Yeah, not that casual though, but yes. And it's the case with any technology I follow. It's the same with Java. You cannot catch up with Java. It's impossible.
Yeah, I gave up on this like 5 years ago.
It sounds weird. Java is just a single language.
Yeah,
and it's a very established language. It's nothing like JavaScript or I don't know, TypeScript. They have new frameworks every day. Even in Java, you cannot really follow, and it doesn't make any sense to read whole while doing CoinFoc. You just need to casually talk to people, and they will tell you things. And probably conferences. Yeah, by the way, conferences on data engineering are quite awesome.
Okay. Cool. Thank you very much. I ran out of questions. I still think there's plenty to figure out, but like we have that much time. So thanks again. Anything you want to wish to our audience?
Yeah, folks, I want to wish you lower latency, higher throughput, and be happy.
Okay. Thank you very much. See you later, and please make sure.
Did I mix them up? Lower latency and higher throughput. I'm not sure if I thought it.
Yeah, you said it correct, but I will check the recording. So yeah, folks, make sure you subscribe, because like next week we have 2 awesome speakers. So yeah, keep up to date with the channel. Thanks, Pasha. Thank you.
They have my contacts somewhere. You can actually contact me and ask questions.
Yeah. So I will leave everything like down below in the description. So please wait if it's not there.